Okay, ladies and gentlemen, it is time for us to continue our discussion with Object-Oriented Programming 2 with a close look at static members. Now, static members should not be anything new to you. The only thing is we haven't had an official lesson on them. We have been using static members since the very beginning. If you think all the way back to the Hyperion project in Volume 1, we used static members there. Through all of our very small, quick, cheesy applications that we put together to demonstrate specific concepts, static members were always there. Think about it. What's main? Main is a method. It's a very special method. It's our entry point into the application, but it is a static method, making it a static member. So like I said, everything that we've put together has always had a static member in it. Now, as we progressed into Volume 2, we started getting a little bit more specific with our demonstrations, and we started talking more and more about types. We got into value types and reference types, and we started drawing out what the stack looked like and the heap looked like. If you recall, we had a couple demonstrations where, well, we just happened to have a static member that had to get drawn into the graphic, and it got drawn into the heap inside the class itself. So there has been some talk on static members, and every time I have given the very quick talk as to what they are, I kept saying, but we'll come back to them, and we'll come back to them in the static members video, and that's where we are now. I guess what I'm getting at is you probably know exactly what static members are, but we need to do the video, so here we are. Now, we're only going to focus on fields and methods. So static fields, static methods. Those static properties, and later on when we start expanding and getting into more member types, it's all pretty much the same stuff. It all applies exactly as I'm going to describe here. Now, there are a total of 5 different things that we need to cover by the end of this video so that you have a really good understanding of what static members are and how you can use them, well, to their fullest potential. Now, as we all know, with these detailed lessons, I like to write out what the objectives are so that we can come back and check them off, make sure we don't miss anything. So first, what are we going to do? We're going to take a look at the difference between instance and static members. So the difference between instance and static members. And we're going to do this through writing a very simple application that basically has a class that keeps track of how many instantiations of that class there's been. So in other words, a class that keeps track of how many times it's been instantiated. Very powerful stuff, a very common use of a static member. So we'll take a look at that, and by doing that, I'll also throw some instance members in there, and that will allow us to clearly see the difference between instance members and static members. The next thing we need to do, and this is just, a byproduct. We automatically get this when we start writing this code out, but we need to, demonstrate how to define static members. So how to define static members. Technically, we can cover that one right now. It's real simple. Define a field and use the static modifier. Over. Same thing goes for methods. All right, let's move on. Next thing is going to be how to access and initialize. So we'll go ahead and say initialize. Static members. And how we can go about accessing static members. And then finally, we're going to wrap the whole thing up with just a general discussion about things to keep in mind when working with static members. Some of these things are going to come across as rules that you need to comply with when dealing with static members. So we'll just call it general notes. All right, so that is our objective. These are the 5 things we need to have a very good understanding of by the end of this video. So let's go ahead and start talking about the difference between instance and static members. First of all, I'll give you just a quick blurb, and then after the blurb, let's go ahead and write out some code and draw a picture of what is taking place in memory. And that's going to make everything crystal clear, though none of this technically is new. So a static member is a member that belongs to the class and does not require any instances of the class to be created before you access it. Now, I have said in the past that static members belong to the class, but the key thing here is not only does it belong to the class, you do not have to instantiate the class to gain access to the static member. All you got to do is, well, talk through the class to the static member. Ta-da! It's that simple. Now, an instance member, on the other hand, is associated with each instantiation of the class. Translation: an instance member belongs to an object. So every time you instantiate a class, boom, now we have an object. All of the instance members belong to that specific object. Okay, so if we create 3 instantiations, we now have 3 groups of the instance members. And I'll, again, draw this out here in just a second. Actually, let's just do it now, because that really does make things clear. So I'm going to come over here and add another magical page, and we'll hide this just temporarily. And now I know it's going to take just a second to write this, but it's going to allow me to come in here and trace through things and all that good stuff. So let's go ahead and start out with a class. And I'll pick on game item again. All right, in this class, what is the objective of this class? Well, I am wanting it to contain a private health and a private name instanced member. Okay, so every time we instantiate game item, we make a player, we make an enemy, whatever, it will always have its own state of health and a name. Okay, now I want to create some sort of logic here that is going to allow me to keep track of how many times I've instantiated the game item class. So at any time, I can ask the class how many game items exist in the game. So that's the goal. That's what we're looking for. And we accomplish this through both instance members and static members. So first of all, let's go and throw the static member in first. So everything is, of course, going to be private. So here we are with a private static, and type's going to be an integer, and count. Count's job is going to be to hold the number of instances that have been created. All right, so now let's go ahead and define a couple instance members, because the count, of course, is a static member. So let's create a private integer called health. So that guy's going to keep track of the health of the game item. And then let's turn right around and create a private string. And this will be the name of the game item. All right, very good. Now the next thing that I want to do is create some sort of method that will allow me to get the count of the game item objects that have been created. So some sort of method name that would make sense, a verb name, get count. That makes sense. Now, in this particular case, though, we don't need get count to be an instance member, because we don't need every object that's created to have a get count. That wouldn't make sense. We just need one get count. And because we only need one get count, then we'll just make it static. So here we are creating public so that we can access it outside. So we've got a public and static. So now I'm locking it to the class. It's going to return, because this is a method, so we have to put a return type. It's going to return an integer, because that's what our count is. And it's going to be called get count. Okay? And what does get count do? Well, it's very simple. It simply returns the count. And let's close that off. All right, so far, so good. Now we've got some functionality that exists inside the game item, but we need to get the help and the name initialized, and we can do this through the constructor. So let's go ahead and explicitly define a constructor that takes in two parameters, a health and a name. So we'll do a public, because we've learned all about constructors now, and we know if we do private, we're going to create a problem for ourselves. We'll never be able to instantiate the class. So we've got a public game item, and this game item will take in, over in the right-hand corner, an integer called health and a string called name. And let's go ahead and define the body of the constructor with setting the data member, the instance data member health, to the parameter health that we've just received into the constructor. Now, we talked about this in the last video over constructors. How do you gain access to a data member when its name is the same as a parameter name and both of them are now kind of in the same scope? Because the parameter is going to hide the data member when the names are the same. Simple. We just used this. So this dot health equals health. So now we can play with both of these in the same scope. And let's do this dot name equals name. So the health that comes in and the name that comes in get assigned into the instance members, okay, into the data fields or the data members. All right, now we've got one more thing that I want to do. Check this out. I'm going to do count plus plus, and this is the heart of the demonstration right here. Now let's go ahead and close off our public constructor and close off the class. Now notice count plus plus doesn't have this in front of it. There is no this dot count plus plus. You can't do that. Static members belong to the class. This is a keyword that you can use to refer to the current instance, the instance you're dealing with right then at hand. Well, you don't have a right then at hand in an instance for count because count is static. It only belongs to the class itself, and there's only one of them. So there's no reason to say this count as opposed to that count because there's only one count. All right, this very simple class actually has a very powerful feature built in, the ability to keep track of how many game items have been created. Now what I'd like to do is come over here with my beautiful drawing skills. And I'm going to cheat. I'm going to use the shift button. Oh, so much nicer. And draw out some memory. Gotta love my representation of memory, eh? Boxes. This, as we all know, is our managed heap. It is our heap. And on the heap, we now have the game item type object created. So let's see, determining how big I want to make them. So here he is, game item. So he gets loaded over there, and we know he's got some information where he's pointing back over to another object, and we'll get into that when we get into inheritance really soon. And we know that down here and below in our graphical representation, we've got our lookup table, and inside our lookup table, we're going to have get count down here, so that we can look up the get count code when we call upon it. And then, of course, we have any sort of data members in here, any sort of fields. So what static fields do we have right now? Well, we only have one. Let me come over here and draw a little arrow pointing to it. We have count. So what I'm going to do is I'm just going to represent these fields as boxes. So this will be count. And we've talked about when the type object gets created on the heap, when the class is put onto the heap, everything gets initialized to 0 or null, depending upon what type it is. Okay, so count's an integer, it gets initialized to 0. Very good. Now, this is it. We're done. Now we need some more code if we want to see something interesting happen. So if I was to come up here and say game item, say we put this in main or something, player equals, and we do a new game item. Now, since the public constructor is looking for some initialization data, let's go ahead and send it a value of 100 and the name Bob. And terminate. Now, if we were to run right now and we execute this line of code, what happens? Well, the new keyword and us calling the public constructor is going to create an instantiation of game item, meaning we have now created an object of type game item. So here is that object, and I'll just put player up here. And let's do a little setup. We know there's an object type pointer that's pointing back over here to my game item. So we know our class that we're associated with, so we can get back to our method lookup table and all that good stuff. So in here we also have our fields now. So let's go and create some fields. Well, what fields do we have inside of player? Well, it's simple. We've got health, and we've got the name. And we know that we sent 100 into the public constructor to initialize health, and then we had the line this dot health equals that 100 that we sent in, so 100 gets placed in here. Then we had the name Bob get passed in, and this dot name, which is this guy right here, gets set to Bob. And then finally, the public constructor is going to, you could just say, send back to player the reference to this guy. So now player knows how to get to him. Simple enough, all right? But there's one more thing that takes place inside this constructor that I kind of skipped over because I want to highlight it here. Count plus plus. Like I said a few minutes ago, this is the heart of this demonstration. Count is a static field, so it exists in the class itself. It has already been initialized to 0, so 0 plus 1 is a value of 1. So now, this guy, back over here in game item, just became 1. Very cool. Check this out. If I was to turn around and do a console.writeLine, so we know we're going to simplify this by just saying write with my comment marks in there. But if I wanted to write out, you have X number of game items created, how would I do it? Well, I wouldn't say player dot get count, because see, at the moment what I'm wanting to do is I'm wanting to talk to my get count method. I want to pull information out of here. I want to pull that count out. So that's what I need to do. But he is a static method. And since he is a static method, I can't talk to him through, even though he is indeed public, right? I can't talk to him through the player reference. I have to talk to the game item itself because it's static, meaning it belongs to game item. It belongs to the class. So I could do console.writeLine, and then I'd come in here and say game item dot get count. And just treat it like a regular method. And what is this going to return? It returns count back out. What is count currently? Count is currently set to a value of 1. Let's look at our heap. How many objects do we have on the heap? We have 1. It's a player. Works beautiful. Now let's go ahead and do this same line again. So if I was to come in here and say game item enemy equals new enemy. So So we're going to do a new game item. I said new enemy. Whoops. So a new game item. And we're going to put a very weak enemy into the scene. And we're going to call him X, the mysterious X. Those guys are so easy to kill because they only have 25 points of health. Well, what happens? Once again, new calls our constructor. So here is our public constructor down here. We're going to create a new instantiation of game item on the heap. So over here on the heap, let us go ahead and create a new instance of game item. So here it comes. Very nice. Of course, we know we have a little bit of overhead information with it that is going to point back to game item. And we'll come in here and add enemy just so that we know who we're talking about. And as the constructor goes through, we know we have got some instanced members. We have health. And, of course, we have name. And health gets set to what? Well, sending into the constructor, we sent it 25. And coming into name, we sent it X. And then this final line in the public constructor executed, which was count plus plus. So we take the value of count, which is 1, and we increment it by 1. And what do we get? 2. And then, of course, we send out the reference back to enemy, so the enemy knows where enemy on the heap is, where the actual instantiation of game item. All right, looking good. So now if I was to turn around and say, write out. So let's go ahead and write out. Again, I want to find out how many instances of game item have been created. How many game items do we have? Simply say game item, because I got to talk directly to the class, dot get count. Open, close, and what am I going to get? I'm going to get whatever is currently in game items count field, and that is a value of 2. Well, let's look at the heap. How many objects do we have on the heap? We've got 2. We've got a player and we've got an enemy. Very, very powerful setup right here. Okay. Now, obviously, there are things that we will need to do if we wanted to start removing these guys. And based off simple stuff that you've seen in the past from, well, knowledge reviews and dealing with lists, the easy way in itself is every time you go through and you remove an item out from the list, make sure you take GameItem.count and decrement it 1. So you've taken the guy out. You've made sure that count stayed properly in sync with the number of items that have actually been created. Logan, is there anything you want to add to this?
Well, the key to this whole example is the fact that you can have static members alongside instance members in the same class. And what this allows you to do is set up a scenario where a class can manage itself as far as instances are concerned.
That's right. Another
way this could be approached is you could have your game item class, and then separate from that, you could have a static manager class. And that manager class is what could contain the count. So you'd have a manager that is actually separate from the game item class.
Mm-hmm.
But the beauty of having static and instance fields in the same class is that in this case, the class can manage itself. As you can see on the heap, the instanced members will go along with any specific instance, but we can still keep static information along with the class itself.
Right.
So that as we spawn more of these game items, we don't need any kind of external management system. We can just go back to the game item class and ask how many instances we've made from that class.
Exactly. So I'll just wrap this up. Like I said, once we drew this out on the heap itself, you would have a really good understanding between the difference of instance members and static members, and we have that here. With instance members, and that would be, well, hang on, and undo that, there we go. That would be this guy, and this guy right here. Every time we instantiate the class, we get a new set of those fields. We get a new health and we get a new name. And we've already talked about this. This allows us to set the state of that object. The state of player has a health of 100 in the name of Bob. The state of enemy has a health of 25 in the name of X. So they are different from one another. So that's the whole thing here with the instance members. They get instanced. Now, what about our methods? Do instance methods get instanced? No, it's not like that. Instance methods would show up down here in the method lookup table. But the key thing is when you work with an instanced method, it is going to be working on the instanced fields for the object that you're dealing with at that moment. That's the key thing, and we'll talk about that again when we get to the end of this lesson and we start going over some of the basic rules when dealing with static members. So again, when you're dealing with instanced methods, it still appears over in the type object itself, in the method lookup table. The key thing to remember is it's not doing any work on static members inside game item. When you call upon it, it's associated with the particular instance of game item that you're currently dealing with. Okay? So that is when working with instance methods. So there you go. Logan, anything else you want to add to this?
No, I think that covers it pretty well.
All right, fantastic. So we're going to go ahead and pull out yet another whiteboard. Let us do it now. So there we go. We'll hide all of that scary looking stuff. Now, the next thing I want to talk about is initializing and, of course, accessing. Well, we just saw accessing. So it's going to be initializing static members. There are two ways we can go about this. So I guess I can jot all this down for those of you taking notes. So initializing static, and I'm not going to call it static members. I'm going to now call it just static fields. Because think about it, that's what we're initializing, right?
Right, because one doesn't initialize a method.
Ooh, that'd be
one initializes state. State is represented in fields.
That's right. So there's two ways. One, direct. So direct initialization, and number two, and we have seen number two, and it's through a static constructor. Okay, these are the two methods that we can go about doing this. Now, it is important, as we start demonstrating this, it is very important to make sure you understand the sequence in which things are executed when dealing with static members. This is so, so important. I'm just going to write down order. Now, the order. This is really important, and this ties back into our constructors video. Remember, I said static constructors fire when the class is touched. And that's true. When externally, you do anything to that class, you're going to fire off the static constructor. But now, let's climb down a step deeper and look into the class itself and what is actually happening. Because the static constructor does indeed fire before anything external can use it, right? It gets fired that very first time. But initializations take place first. I didn't want to get into open up the whole can of worms in the last video and start drawing all this out. So what happens when you access a class and there's static fields in there that are being initialized? That occurs before the static constructor fires. So order is going to be number one. We're going to have static initializations. And after static initializations, the next thing is going to be the static constructor. And then finally, whatever you did externally to provoke this to happen, okay? Because again, you're poking it, you poke the class, and the static constructor fires. Well, that's true. But right before that, the static initializers take place because, well, all of the fields are being initialized. So I have got an example that has been inspired by Microsoft. It comes from one of their examples, and I have modified it to make it just a little bit more mind-bending. And at first glance, if you just look at it and you're not aware of the order and the specific rules when dealing with static initializations and static constructors, you very well may get the answer wrong. And yes, there is indeed an answer here. So what I want to do is write all this out. Let's see, do I have enough room to write it? I think so. So let's go ahead and create a class. All right, I'm looking for as much room as I can find. So give me a second. I'm being picky. So if I was to come right about here, and draw a line down, just to kind of keep things nice and neat. All right, so if I had a class A, and again, bear with me. Let me give myself just a little bit more room. About there. So class A. And inside class A, what we're going to have is a public static integer x. Now x needs to be equal to something. We'll come back to that in a minute. Now we're going to create a public static integer z. And we'll go ahead and set this one. Z is going to be equal to minus x. Terminate. Okay, ooh, so z is affecting x. Very interesting. Now what I'm going to do is create a static constructor because I want you to see initializations and this constructor so you can put the whole big picture of what's going on together at one time. So we're going to have a static. Now remember from the last video, I can't come in here and put any access modifiers. So static A, because that's the class name. And now let's put some code inside here. X, whatever x is, it's going to be plus equal to 1. So we'll increment x by 1. And then what I want you to do when you write this out is just write out something like in static constructor. A. This way we can visually see what is happening. All right, next. What I want to do, well, that's actually it for A. So let's go ahead and close off class A. All right, now let's create class B. So class B. And in class B, let us go ahead and create a public static integer called y. Now let's go ahead and set it. Y is going to be equal to a dot z plus 1. Terminate. Now let's come back up here to class A and set A. A is going to be equal to b dot y plus 1. Terminate. Now right now, if you happen to be watching this thinking, why would I do something like this? Okay, I'm having a hard time with the logic. Why would I? No. Just relax. See, it's cool. I'm demonstrating the order. I'm proving to you how things fire off when we call upon classes that are filled with static initializations and a static constructor. So just relax. You're not going to do anything like this for real, not that I can think of. It's just for demonstration purposes. Okay, so now we've got this very interesting scenario set up. Let's go ahead and create the static constructor for B. So static B. So there's our constructor. And inside here, we're just simply write out in static constructor B. And we'll close this off. And then let's create a public This is going to be a public method that I can call upon in class B to trigger off this chain reaction that's going to happen. So a public static void, we'll just call it fire, meaning to fire off the chain of events. And in here, what I want to do is write out something along the lines of fire x equals, and whatever x is equal to, and y equals, and whatever y is equal to. So of course we know that x is what? In reality, x is going to be a dot x, and what is going to be y? Y is simply going to be b dot y. Okay, so that's what I'm looking for. Throw a little dividing line in there, make it easier to see. We can close this off, and we can close the class off. So back in my main method, to fire this whole thing off, all I need to do is b dot fire. Terminate. Now, if you'd like to have a little bit of fun, pause the video right now, pull out a sheet of paper, and try to work this out and figure out the order in which things are going to be printed out to the console and what is going to be in X and what is going to be in Y. Now, for those of you that are looking at this and thinking, wow, this looks like some sort of crazy algebra type mathematical problem, it's not. The fact that we're using A and B, X and Y, don't let that confuse you. The class name is A. The class name could have been game item. It could have been game item dot X, right? Just don't let that confuse you. I'm just using very simple letters here. All right, so if you want to pause it, do so now. Treat it like a knowledge review. I'm going to draw a line right here. Oh, so close. So close. All right, I'll be a little bit quicker at that. Much better. Okay. Now, let's trace through this and see what really happens. What we're going to be doing is following our order. So the very first thing that happens is, of course, these two classes get set up on the heap, okay? And we fire off B. So let's follow what's going to take place. As a matter of fact, if you don't mind, I'm going to come over here and open up my tools. Drag this in the far corner. And, ooh, it already knew I want it red. All right, very nice. So here we are. We're calling upon b.fire because we got to talk to the class directly because fire is a static method. Okay? So we call fire, and what happens? Well, it says to write out, we're touching A. So it wants us to write out what is in class A's X static field. All right? That means we've suddenly shifted our attention up here. So let's put down here, currently on hold. Okay, so now we're up here. What happens up here? Well, up here, we're also dealing with, hang on, taking a look at this, A.X, and we've also got this guy that's going to be a problem. So, we've got all of these different initializations. If you think about it, it looks like we've got ourselves in a bit of a situation right here. Because A.Z, but Z deals with X, and X is equal to B.Y, suddenly we've got this situation where it looks like we're going down here, and we're coming back up here, and we've just created a paradox or some sort of recursive action that's just going to loop forever and ever and ever, and oh, it's a nightmare. Okay, no, let's just start drawing this out because it's really simple. When we called fire, okay, what's the first thing that takes place? We deal with all of our static stuff inside of that class. Right now, since we just called fire, where are we at? We're inside class B. So the first thing we need to do, looking at our order right here, is call our static, or take care of our static initializations. Well, we've only got one. That static initialization is right here. So Y, so here's going to be B. So Y is equal to, well, it's already equal to 0 because we know when the object type is dropped over on the heap, everything is initialized to 0. It's currently in 0. Now, in populating it with something other than 0 in the initialization, we got to call to A. So let's, again, hold what's going on right here. Let's come up here to A. So now our focus is in A. Now let's come back over here and take a look at order again. Order again tells us that we first do our static initializations. So let me draw A down here. Okay? And the first thing is going to be right here with X. X equals B.Y plus 1. We can solve this. Why do I say that? Because Y currently has a value of 0 in it. Okay, so let's put it down here. What is X going to be? X is going to be equal to 0 plus 1. Okay, what does that mean? X equals 1. All right, very good. In the static initializations, the next thing's going to take place right here. Tricky, tricky. Remember how your expressions work. Minus minus X means take X, decrement it by 1, and then use the result and put that into Z. So to do this line, so keep up with where I'm at. So I'm right here. To do that line, the first thing we have to do is decrement him, because the minus minus is a pre-operation as opposed to a post-operation. So X goes from 1 to 0. Bummer, he just lost his value. And then we store that into Z. So Z now equals 0. All right, so now we have just taken care of this first part, our static initialization. So now, as far as A is concerned, we've got to finish things off here. We're going to fire the static constructor. And the static constructor says, take what is in X and add 1 to it. X equals X plus 1. X is currently a 0 plus 1 makes X a value of 1. Okay? And then, for the very first time, we're going to write out, so here we are, this will be my manager console window. So we're going to write out in constructor A. Okay, very good. And that's it. So now we have done static initializations and static constructor for class A. Now let's return back to what triggered this. Well, what triggered this was back in class B right here. Remember, that's where we just held. So I just drew a line from where we held coming back in. Now let's do this line. So this line for the static initialization says that Y is equal to whatever is in class A's field Z plus 1. Class A's field Z is 0. That's what Z contains, 0. Plus 1 is a value of 1. So Y just became 1. And let me just drop these numbers in here so you can see what I'm talking about. A dot Z was equal to 0 plus 1. Answer, 1. So that just went into Y. Okay? So now we're back up here. We've taken care of this, the static initialization in class B. Now we've got to fire the static constructor for class B. So the static constructor fires. So here we are. And all we're going to do is write out to the console in constructor B. Even though this is all we see at this point in the console, look at all the stuff that's taken place with fields behind the scenes. All sorts of action going on. All right, very good. So now what takes place? Well, we've done the initialization. We've done the constructor. We can finally come back to that holding spot where I said hold at the very beginning. We're finally dealing with our call here. How funny is that? So now we're going to write out fire. And then we're going to write out X equals, and then what is in A dot X? 1. So X equals 1. And we're going to write out Y equals, and Y is equal to B dot Y. Here's B dot Y. So what is in it? 1. So that's what we get. X equals 1, Y equals 1. And then, of course, execution is going to finally return back up here, and we'll continue on with the next line. Okay? So, pretty clear? This may appear a bit confusing to you. I know I've jumped all over the place, but that is what is happening. In a nutshell, we called upon a static member for the very first time, a static method in Class B. And that's all fine and good. That simply means that Class B must first take care of all static field initializations and then execute the constructor. So even though we called on this static method, we have to first do this and then this. But the unique situation came up while doing static initializations right here. We forced ourselves to have to jump up here to this class because we were dealing with that particular class. We said A.Z, and that meant we had to come into class A and do the initialization and the constructor. And with the initialization in that class, we were able to gain access to the values we needed. In other words, we did not touch or provoke another class. So we were able to work all the way through class A, finish its static initializations and static constructor, then return back to class B and finish its static initializations to get the proper value for Y, and then invoke its static constructor. And once all of that was finally done, our attention came back to fire, and we were able to wrap it all up. Logan, anything you want to add to this?
And the key to the reason that one can solve this is because initialization happens precisely once. Once initialization happens, it does not happen again. This is true for both the static initializations and the static constructor.
That's right.
That's why this is not an infinite recursion scenario. That's why once we get up into A's initialization, where x is equal to b.y at the very beginning, the reason accessing b.y doesn't cause a recursive scenario is because the static initialization for b has occurred, the static field initialization.
That's right.
Even though it's not actually set yet because we're in the middle of setting it, it's still marked as, okay, we have begun the initialization. We cannot begin the initialization again. That means the value is going to be taken as the value.
That's
we
right.
don't begin another initialization. The value right now, having not been set, even because the initialization isn't finished, is currently 0. And that begins the chain of why we can begin to solve this. Initialization can be begun exactly once.
Exactly. If you don't mind, let's write this one out real quick over inside of Visual Studio. It won't take but a minute, guys.
Sure. Let's jump over to Visual Studio and begin a new project. And let's begin writing our classes A and B. So we'll start off with class A. And class A is going to contain two public static fields. We'll have public static int x, which is going to be initialized to b.y. And IntelliSense is noticing that we don't have anything named b, so I'm going to code it all in even though we don't have b just yet. We have static int x equals b.y plus 1.
Okay.
Then we also have a public static int z, which is equal to minus minus x. All right?
Okay.
And we have a static constructor in A, so we have static A, which simply writes out, or actually does two things. It increments x, so x plus equals 1, and then just notes the fact that we're in the static constructor. So we'll write out to the console, and we'll write out the line in static constructor.
A.
Right, okay, right, because we need to see which one, because we're going to have another static constructor when we get to B.
Okay.
All right, so we write out that we're in static constructor A, and that takes care of the A class. Now we can move on to class B. And class B is going to have one static field, so we'll have public static int y, and y is initialized to a.z plus 1. And then we have a static constructor in B as well, so we'll have static B. And static B is simply going to write out the fact that we're in the static constructor. So this will be, again, console write line in static constructor. And messed up. As a matter of fact, let me just,
Okay.
In static constructor B.
Okay.
And finally, we have the public static fire method for the class B. So this will be public static void fire. And fire shows that we're in fire and then shows a.x and b.y. So we'll do, again, a console write line. We'll write out fire, just to indicate that we're in fire. And then x is equal to, then we'll jump out and concatenate the value a.x, then concatenate to another string, which will be y, or do you want to put a dividing character?
Yeah, put a pipe symbol in there. Yeah, that's good.
All right, so put in a pipe symbol and then say that y is equal to, and we'll jump out of the string, add on to that b dot y. And that should allow us to finish off this right line. And then we have our classes.
All right, so now all we need to do is call upon B's fire and then do a console.readline.
Okay, so I'll jump up to the static main method, and we'll say b.fire. And then a console readline, just so that we can hold up execution and see what was written. All right.
Okay, so real quick, we should see that both x and y are a value of 1. Let's go ahead and run it. And there we go. Check it out. Exactly what was written back over on the whiteboard. The first thing we saw was as a matter of fact, I'm just going to grab my pen here and jump back and forth. So we've got in static constructor A, in static constructor B, fire x equals 1, y equals 1. So coming back over to the whiteboard, and remember, this was our little console right here. So in constructor A, check. In constructor B, check. Fire x equals 1, y equals 1. Check. Beautiful. That is exactly what we were looking for right here. So now you can see exactly what took place internally in regards to all of these static members firing off based off the two rules I just gave you. Static initialization takes place first, and then static constructors take place, okay? Because obviously x and y are being manipulated all over the place. And you can see that by tracing this through, we did indeed end up with the correct results. So there you go. Logan, anything you want to add to that?
No, I think that makes for a really good example.
All right, very cool. Well, let's go ahead and close this out and jump back over to our whiteboard real quick. Let's see, the next thing we want to talk about, I got an idea. How about just a really quick example of a practical use for a static constructor, a very simple one. So to do this, let me come over here and first of all, let's switch our color back and hide our tools. And then let's add in another sheet and hide this sheet. Okay. So another example could be something like class. This will be really quick, guys. Actor. So let's say we were creating some sort of actor management system, as Logan was mentioning a management system earlier. Then inside here, we could create a static list of actors. So type actor, and then we can call it actors. Terminate. Then we could have a static constructor actor, and inside our static constructor we could say actors is equal to a new list of actors. Type actor. And call its public constructor, or its constructor, and end that off, end this off. So now what have we done? On the heap, we've got actor sitting there. So here's actor. And, of course, he has his overhead information. And then he has his method lookup table. But inside here, he's got a list. And this list is going to contain a list of actors. A list of these guys. Okay? As they're instantiated. Of course, we haven't written all that code. But this is just an example of how, with the class, we can just do setup right off the bat to go ahead and get that list in place, ready to go. And there you go. Anything you want to add to this, Logan?
Right, just showing an example of where you would want to use a static constructor to initialize something.
Precisely. Now, you could go a whole lot further with this. The nice thing about, obviously, just a couple things to throw in there real quick. Right here, I could have simply said equals new list of actors. I could have even done something else kind of cool. When you're dealing with a static initialization for a field, you can set that field equals and then call a static method and then have initialization take place in that method. Though to be honest with you, I'm not too sure why you'd want to do that when you could just take that information and put it in the static constructor itself. The static constructor really does provide a very good place to do static member initialization.
What it comes down to is when initializing static members or static fields, you have several options. If it's a simple value, you can just initialize it directly on that line where you define the field. If you have some more statements that need to run, for example, what if you needed to look at a file on the hard drive to determine what actors to create? In that case, a static constructor would be useful because you could do any statements necessary leading up to the creation of the actors list and then actually perform it.
Exactly.
Or even go so far as to use the return of a method, another static method, in order to fill in a static field. But again, that all comes down to what would be most efficient for the static fields that you have in the specific class. Because, as you were talking about a second ago, assigning a static field using some other static method leads to a scenario where if you had a lot of fields and initialized them all in that manner, you would have a lot of just initialization methods that were separate from one another, which would get very messy very quickly.
Right.
So in that case, it would be better to just put everything in the constructor and just set the fields from the constructor. Or if the values were more simplistic, just set them directly.
Exactly. So, simple. Now check this out. This is pretty nifty stuff right here, because now we have a list of all of the guys that we create, which means instead of having a static field called count to keep track, now we can just take that list, actors.count, and now we can find out how many we have.
We not only have the count, but we can access everything.
That's right, we can get to them. This cool little example is going to be demonstrated at the end of this section when we put together that little actor management system so that you can actually see this in action. So we'll be coming back to this real soon. So that really brings us to one final thing, and that's me wanting to just talk about some general things to remember when dealing with static members. So let's go ahead and bring up just one more sheet of paper, and I'll just jot some quick notes down for you guys if you're interested. So you can call them rules, you can just call them things to remember. Alright, so things to remember are, number one, a static field has only one storage location. And we've seen that. Create a static count as a demonstration a couple back. What did we see? We saw that the type object had the field inside for count, and there was only one. It did not travel along with instantiations of the class. There was just one storage location for that particular static field. Okay. Number two. Static members belong to the class and do not require any instances to be created before accessing. This is the very first thing I said. So static members belong to the class. So they're going to be simply accessed by doing class name dot field. So this is how you go about access, and we've all seen that now. So you don't talk to the object. You don't say player dot, not like that. You have to actually do the class. You have to actually use the class identifier. So it would be like game item dot and then the field itself. 3. It is not possible to use this keyword to reference static members.
And that goes back to rules or guidelines 1 and 2.
That's right.
If there's only one, well, instances are going to be incredibly less useful there. And under 2, if it belongs to the class, there's no reason to have access through instances when it's the class itself is the place where the data is actually being stored. That means that it's in an entirely different world and place than any given instance.
That's right.
This keyword is used in reference to a specific instance.
That's right. All right. The last two are the two I really want you to pay attention to. These are very important. You cannot access instance members inside of a static member. Okay? So cannot access, this is so important, instance members from inside static members. So let's say I have my type object on the heap. I have a static method in it. The static method can access other static methods. It can access static fields. But how could it possibly access an instanced member? Doesn't know where they're at. Okay.
Right, because it's a class. The class exists before any instances are made.
That's right.
And continues to exist no matter how many more instances are made. So if there are multiple instances, you wouldn't know which member you're actually calling.
That's right.
And if you had just loaded, you wouldn't have any instances left, so there would be no field to access or no specific state for a method to be called under.
Precisely. So on the flip side, though, you can access static members inside of instance members. So can access static members from inside of instance members. Because out here, now we have our instance of, let's say, game item, it's player. And remember, he knows where this guy is at all times. He keeps that pointer back to the type object. And so if we wanted to access one of these guys, it's not a problem. Okay, so we could access that, we could access that. We have access to all of it. So just two big things to remember. You cannot access instant members from inside of a static member, but you can access static members from inside of an instance member. And with that, let me go ahead and bring up, well, first of all, how good of a job do we do? Oh, yeah! Oh, this video is just full of love. Let's go ahead and turn this all off. And let's jump, yeah, there we go, all the way back down. So we took a look at the difference between, and once again, let me get focused, there we go. We took a look at the difference between instance and static members, and we saw how instance members go along with each instance of the class, and static members, well, they belong to the class, so you only have one. From there, we took a look at how we can go about defining static members. It's really just using the static modifier. That's all there is to it. And from there, we saw how we could initialize static members, and we took that as far as we could. We talked about the order in which initialization takes place. Basically, the initializers or initialization goes first, then the static constructors fire. So very important to understand that. And then from there, we took a look at, of course, how to access static members. That's simply done by referring to the to the class's identifier. So class identifier, so class name, dot, and then the static member you're wanting to reference. And then finally, we just gave you a few general notes about static members, and that pretty much wraps it up. Logan, is there anything that you think needs to be added into this?
Nothing I can think of. I think this really wraps it up, puts it all together.
Okay, excellent. Well, guys, I hope you got a lot out of that, and that is going to wrap up this video on static members. Thanks a lot.